an introduction, so we'll have just a few minutes for any latecomers to come on before Alph starts speaking. So hello and welcome to the GC3 Green Chemistry Innovation webinar series. I'm Monica Becker and I'll be moderating the webinar today. We're very happy to have everyone here. And for those of you on the call who are new to the GC3, I'll just let you know that we are a business-to-business membership organization working to advance the application of green chemistry and design for environment across sectors and supply chains. Our member companies span 13 major product sectors and the entire value chain from chemical manufacturing to retail. And our members bring their leading-edge experience, know-how, and unique perspectives to collaborative GC3 projects, webinars, and of course our annual roundtable meeting. So this is the third webinar of our GC3 Green Chemistry Innovation webinar series, where we're examining innovation models and programs that either are being used or can be used to advance green chemistry research, development, and commercial adoption. As some of you know, during our first webinar, we heard from Professor Kai-Cheng Lee of Oregon State University, who has an impressive track record of commercializing green chemistry technologies in partnership with industry. In our second webinar, Rui Resendez, the Executive Director of Green Center Canada, presented their unique and successful business model for pulling green chemistry ideas out of the lab and into commercial application. And if you missed either of these excellent presentations, there are audio archives on the GC3 website, and I do encourage you to listen in. If you have any trouble accessing those, just send me an email or Sarah Shields from the GC3, and we can help you get access to those. And today, we're very pleased to have with us Dr. Alph Bingham, founder and board member of InnoCentive, which is a global leader of open innovation and crowdsourcing innovation. And what I'm going to do is just very quickly go over some logistical information. Alph, if you can advance to the next slide. For many of you that have been on these webinars before, this is old hat, but what I'll let you know is that we will be asking Alph to go through his entire presentation, and then we'll do Q&A at the end. I encourage you, if you have questions during the presentation, type them into the Q&A box. You can access that by putting your cursor at the top of the screen, and a drop-down control panel will come down. You click on the arrow all the way to the right and select Q&A, and a little box opens up. And you'll be able to type in your question. And I'll be collecting the questions, and we'll be reading them out to Alph at the end of the presentation. So if something occurs to you, go ahead and type it in, and we'll just collect them as we go. And then we'll also have you type in questions at the end if you'd rather do that. So without further ado, I'd like to introduce our speaker. Very excited to have Dr. Alph Bingham with us today. And again, Alph is the founder and a board member of InnoCentive. He is a serial entrepreneur, having founded a number of innovation-driven companies such as Your Encore, Coalescix, Indigo Biosystems, and Seriosity. Alph spent over 25 years with Eli Lilly and Company in pharmaceutical R&D and portfolio management. He also co-authored a book called The Open Innovation Marketplace. And Dr. Bingham received a BS in chemistry from Brigham Young University and a PhD in organic chemistry from Stanford University. So Alph, please take it away, and thank you for being here.
Thank you, Monica. And thanks to all who attended. Good afternoon or good morning, as the case may be. Welcome. Let me just start with one slide to kind of level set, and then we'll get into some of the meatier bits of this. We're going to talk about crowdsourcing and green chemistry, the intersection. Why would crowdsourcing be a better way to tackle some of the problems in green chemistry, to accentuate the awareness? And I'm going to punctuate primarily remarks on the process of crowdsourcing with green chemical examples of problems that we have solved already since our founding. Now, crowdsourcing is something that you're all familiar with in one form or another. You're familiar with it if you've watched any old westerns. You're familiar with it if you've watched the TV show Dog the Bounty Hunter. Basically, it is in essence a bounty hunting type model in which a problem or a need of some type is broadcast to the community at large, and individuals self-select. So again, if I can go back to the metaphor of bounty hunting, you post the outlaw's picture on the sheriff's door, and you allow anybody to opt in as a potential problem solver, as a potential law enforcement officer, go out, track down the outlaw, and bring them in. Now, in the same way, that outlaw could be a technical, complex problem. That outlaw could be something like identifying new stars that have not yet been located and named. Any type of a problem that can be modularized and outsourced to the crowd. Now, why would that be a preferred mode of problem solving? Well, in the first case, this gives the problem much broader exposure than you can ever get in any type of a closed system. That broad exposure often brings far greater diversity of thought process to the solving of the problem, and therefore lateral type solutions, solutions that are usually not thought of. It is almost inescapably the case that when a problem is solved within our crowdsourcing environment, within InnoCentive's crowdsourcing environment, the solution not only came from somewhere outside the field, but came from a perspective that the field was not even considering or thinking about when the problem was solved. As you broadcast problems to a crowd, there are some follow-on benefits. For one, the crowd becomes more aware of the need, and in the case of green chemistry, that's an important part of the exposure. And the in the tens, hundreds of thousands, even in the millions. So you're talking about enrolling in a very active way an enormous population in whatever cause it is that you're undertaking. Now, I'm going to talk in subsequent slides about open innovation versus closed. So I'm going to park that notion for a minute, but I'm going to acknowledge right at the beginning here, openness comes in concentric rings. We generally tend to think whatever our I'm just going to use R&D function as a way of simplifying this. We think of whatever R&D function exists within our corporation, or I'll say organization, because it could be government agency, could be a not-for-profit foundation. Whatever that R&D unit is the most closed form. And the openness in its most open form would be in which InnoCentive broadcasts it to the world at large. But there are rings in between there. There are the ability for people to have far more open and yet still bounded communities. It could be an organization plus all of its retirees. It could be an organization plus its retirees, plus its vendors, plus its customers. It can be an organization plus all of its partners. So there are other ways of constructing concentric rings of openness and appropriate tools for applying to each of those different levels. Now, what I want to talk about is the notion of challenge-driven innovation, and to contrast this way of bringing the way we make progress towards solving some complex problems in contrast to the practices that are more traditional. And I'm going to use those examples of traditional practices not to say that this is better in all cases, and I'm going to even attempt to create some mapping so that you can see that there are circumstances under which a more open environment is beneficial, and there are circumstances in which a closed environment is beneficial. But all of those environments can benefit from this notion of thinking about the problem you have from the framework of challenge-driven innovation. Now, challenge-driven innovation framework in contrast to what? Well, as an example, I'm going to use probably the most familiar innovation process that any practitioner knows of, and that's the StageGate process, in which a problem is taken through some type of a stage, some period of time in which the problem is brought to an intermediary point, and then it passes through a gate to determine whether the solution during that stage, let's call it stage 2, is advancing to gate 3, determining whether it meets the criteria of acceptable and readiness to move into stage 3. And those stages have been named something different by every organization, tailored to its particular environment and the discipline that it focuses on. But, you know, a sample case would be taking something through a scoping stage, followed by building a business case, followed by development, validation. You know, you could have stages of prototyping in there, you could have stages of piloting in there, you could have a lot of different kinds of stages. And that's not the important thing. The important thing is to recognize that we have this coherent and reproducible process. Now, you'll notice that it is intrinsically linear. And in fact, if I just do a Google search on StageGate and grab the images that come up, that linearity is evident over and over again. Arrows circling around. This linearity is imagine in the StageGate process is that the problem becomes more and more solved from one stage to the next. And that in the advanced stages, it is solved to the point of accessibility to the full market. Now, I'm going to, I want you to know what some other frameworks are so that you can think about the framework I'm about to present. That's not to say that StageGate and CDI are incompatible with one another. They can often coexist, but it is to show that there is a different framework instead of stretching something along the axis of time or evolution, we can stretch it along different axes and think about taking a big problem and bringing it ready for prime time in a different way. Make one more point about what a typical organizational structure is when it's engaged in practicing a closed and a StageGate kind of methodology. Most of the work is done on the inside, 80+%, and it's usually plus. It's rarely as low as 80, but 80+% of the work is done internally, with some contracting of work to the outside for a variety of reasons. If we take and break that internal work down, we find that most R&D organizations consist of only a handful of hypothesis generators. There are only a few minds actually hypothesizing new ways of doing things. It consists enormously of a number of data and prototype generators, both scientists and engineers who take these hypotheses and put them into practice in some cyclical testing way in which they generate data that informs the next step of the process, essentially the scientific method. And then there are a handful of designers looking over the overall process and specific details, and then there is some substantial amount of investment in coordination of all of this diverse activity going on. On the outside, there may be some very specialty needs, but in many cases, it is scaling the data generation. It is hiring external contract research organizations that execute at a larger scale and at a cost-effective scale to reproduce things that could be done inside, but it doesn't make sense to do it that way. Now, challenge-driven innovation, on this slide, we start to see what I suggested earlier, which is a way of reframing and rethinking about the problem itself. And what I've put up here, and I've just coded it ALS, and what I mean by that is the disease that is commonly known as Lou Gehrig's disease. Let's say we take a very complex problem. We want to develop an intervention for Lou Gehrig's disease. Now, we could start stretching this along the axis of time, as I mentioned earlier, and build a StageGate process. But in this case, we think about it as being a series of smaller, discrete problems. individual problems that when combined back together again become a intervention or a cure. Cure would, of course, be ideal, but even something that retards the progression of the disease would be an advancement. Something that treats Lou Gehrig's stricken patients. So we dissected into these individuals, and I'm going to go back and I'm going to say a lot more about what these little individual mini projects are, but it is the aggregation of all those mini projects that becomes a solution. Now, the next step is to recognize that each of these individual projects can be articulated as a challenge. A challenge in this case is meant to encapsulate not only a statement of the problem, but a framing of the problem as a module of work that could be put through different channels. And in this case, I've just picked 1, 2, 3, 4, 5 channels just to be a cartoon here. But one of those channels might be your own internal R&D operation. Another one of those channels might be academic research. Another one of those channels might be consultancies, and et cetera, et cetera. One of those channels might very well be crowdsourcing, which we will talk about in more detail. But the notion is that the individual challenge, the individual sub-project, has got a set of properties, and we can match the capabilities of different innovation channels with the properties of that challenge or that module of work, and we can match those up in a way so that the overall project is executed more effectively than it would be if we were just taking it through only one channel and forcing all of these different kinds of needs and modules of work to be accomplished in exactly the same modality. Now, this brings me to the first example of what a challenge is. And in the challenge-driven innovation paradigm, a challenge is a modular and portable unit of work. It is something that can be articulated, and it could be worked on internally. It's portable. Portable doesn't mean you've got to ship it out somewhere, but it could be shipped out somewhere, or it could be executed internally. As an example, in one of the challenges that InnoCentive worked on, and this gives you a little bit of what that outlaw posting looks like on the sheriff's door when we translate it into the internet environment and we post it out there for the world to see. One of our customers needed a green replacement for some traditional polar aprotic solvents. So they had a very specific problem in mind to solve. It was part of solving a wider problem for a market solution. There aren't very many customers that come in and say, I'd like to buy some material that was made by a non-traditional polar aprotic solvent. And so it was a sub-project within an overall project of delivering to the market the product that they had in mind. But this rendered it portable. We were able to post it on InnoCentive. You can kind of see that on the day that this snapshot was made, there were 244 active solvers. I don't know how well the screen projects for each of you, and the text may be small, but there were 244 different individuals who had made a commitment to work on this particular problem. Now, I just put it up here now for a bit of punctuation. We'll go on with the notion of CDI, and I'll come back to some other examples and give you more details on them as we go. So let's say that top channel was crowdsourcing, and of those 244, and I have it written down somewhere, but I'd have to look it up. Of those 244 that intended to work on the project, let's imagine that 50 of them actually brought it to some degree of fruition and submitted it, so that the organization that was looking for these alternatives were given a host of, in most cases, literature-supported alternatives, in some cases even experimentally supported alternatives for the specific problem they were trying to solve. And this array shown here is what looks like a row of green marbles or small peas. This array of 50 possible solutions of the problem was then handed to the recipient organization, and they could go through and evaluate and select from among those options. So if we imagine coming out at the end of this is a series of choices, a series of selections, these little green P-like objects then becoming the solutions to the challenges or problems that were posted and illustrated earlier in orange as part of the dissection. There's then an integration, and they are integrated back up. So we begin with the problem of intervening in Lou Gehrig's disease. We end up with an integrated solution in the treatment of Lou Gehrig's disease. Unfortunately, a problem that while we've solved a few of the small ones, we haven't solved the big one yet. So I don't want you to think I use this as an example of fait accompli. I use it as an example of how you take and imagine a big problem becoming smaller ones. Now, as an example of, and I'm sorry that the fonts didn't translate real clearly here as I did a screenshot, but as an example of how does one challenge become many potential solutions, I'll use a problem that we worked on for the Environmental Defense Fund. They were looking for a nitrate capture system. Essentially what they wanted to do was they wanted to take the fertilizers that were applied to the soil that were not actively incorporated into the growing plant matter, but became part of the water contaminant runoff. They wanted to be able to capture that water, process the water, extract the nitrates, and reapply those nitrates so that we weren't constantly building up nitrate contaminants in the water supply, but also to avoid all of the remanufacturing and redistribution costs on the front end, and that they would become a closed nitrate recycling system under a better set of agricultural practices. So that was, and you can see there's a little detail down there that between 50 and 80% of the fertilizer applied to commercial crops actually ends up as part of this wasted runoff. If we look at what the results were, they had 246 project rooms open. In our work environment, a project room represents a solver who has gone through the process of signing intellectual property agreements, entering a privatized part of our website where they can actually accomplish the work, make submissions, ask questions, and get answers as they're working on a problem. So it kind of represents 246 committed solvers from 45 different countries. That translated into 59 submissions from 17 different countries. So the one challenge that the EDF articulated, which wasn't to solve any one company's problem, was to produce a more efficient ecosystem for solving this across all the various suppliers and agricultural entities. They ended up getting in 59 submissions from 17 different countries. Now, this is far from atypical. I mean, this is the kind of thing that we see over and over again. In fact, I looked on the next slide, and we made the effort to post these on a map. We took the solution for 7 challenges, the first 7 challenges. NASA's worked on many, many more challenges with us, but in 2009 and in 2010, we took the first 7 challenges and we mapped where the submissions were coming from. So you can get some idea of what the numbers are down there, in which NASA had almost 3,000 project rooms opened across this series of challenges. Over 400 solutions were submitted. The challenge type is maybe inside baseball, a detail we may or may not get to in the Q&A, but of the challenge, but it's essentially to say that they ended up getting solutions of some type on all of these. And I think NASA actually awarded the vast majority of these to a winning submission. But if you just look at this map, you realize that that's a level of diversity that probably is unaccomplishable with any type of an internal closed system. In an open innovation model, the way the skills are distributed are very different. We'll take that 80-20 that we had for a closed innovation system and we'll flip it on its head and make it 20-80. And it may even be less than 20, and it may be more than 80. But the inside 20 have got a very different composition. They become skilled in using CDI as opposed to using StageGate. They become skilled in project dissection. It's not easy to take a big problem like ALS, Lou Gehrig's disease, and break it into the portable, modular, movable kinds of pieces that need to be solved by all the different channels and to take advantage of all the kinds of channels I talked about. So project dissection becomes a skill in itself. Orchestration becomes a talent quite distinct from project management because you're orchestrating the efforts of organizations that lie outside your boundaries of control. You need assemblers to bring these ideas back together, and you need a fairly strong evaluation. Well, one of the dangers that we have seen in the past in going from closed to open innovation systems is that they have lost the ability to evaluate the outside ideas because they thought that it was a gift in being able to remove internal resources and conserve on costs, and they stripped their own capabilities out of the inside organization. So maintaining enough deep expertise in the area to effectively evaluate ideas that are generated on the outside is a critical part of this. And then, you know, we can go on, but I think the point is made on this slide. This is I promised at the beginning that I would present some type of a map to say that there is a thoughtful and deliberate way of saying what are the properties of this challenge, this module of work that I've got. What are its properties and how do those properties translate into a rational selection of which channel of innovation I'm going to go down? Is it going to be academic contracts? Is it going to be specialty research organizations? Is it going to be, you know, just scaled research organizations? What external channel am I going to use based on the properties? Now, we've tried a lot of different models, and this is what Dwayne and I finally ended up settling on in the book, was that we took each project and we mapped it as best as possible to one of 7 archetypes. There were the under-the-radar archetypes in which secrecy really dominated. It would be a breach of competitive advantage for others to even know that you were working on that particular submodule. Now, it turns out that while we are fearful that that might be the case often, it's not as often as you might be afraid. It is, but there are certainly a distinct number of instances when you do need to maintain confidentiality at all costs. And in that case, the optimal, the more black that shows on these Harvey balls, the more optimized it is. Internal would be the preferred innovation channel for archetype A under the radar, with the secondary opportunity of using tightly controlled, limited consulting services that were regulated by the appropriate secrecy agreements. Now, I'm not going to walk through. I've got 10 different channels of innovation illustrated along the left side running vertically, and I've got 7 different sets of properties for what these modules are. And I think in the webinar, it's not the best use of our time to walk through and try to articulate what each of those is, because I think we want to get to some other examples. But I put it out there to say that in general, it is unwise to simply think about this as an open versus closed system. It's much wiser to think about it as individual channels and properties of the project or the module of work that you're trying to get accomplished. Now, as we launched this, there were a lot of things we didn't understand. We didn't understand why it might work. We speculated that it might work because of the diversity of thought that would be brought to bear on a problem. And it turns out that we're mostly right in that regard. 90 to 95% of the problems when solved and when the solution is identified, it is identified by the seeking client. The client that is seeking a solution to the problem identifies the solution they prefer blindly. They don't know who submitted it. They don't know what the history or background of the submitter is. They judge it on the merits of the solution itself. And in 90 to 95% of the cases, when we then, disclose what the origin of the solution was, it comes from a source that would never have been hired to solve that problem. Not hired as an employee, not hired as a contractor, not hired as a consultant. It came from a location that was completely off the radar screen of the organization looking to solve the problem. Now, in addition to the whole notion of diversity, we had to come up with some other ways of thinking about why are problems solved so differently in this method. And one of the things we turned to was the work of Paul Carlisle at Boston University, who defines a boundary object. A boundary object, and you can read the text on the slide, I'm not going to read it to you, but a boundary object is a common reference point. It is something that different minds, or a team in some cases, can gather around to collaborate and to think about the problem. And the example I've given in the little photograph there is the automobile prototype. The model, the mock-up that is made so that those designing everything from the rear view mirrors to the sound system can have something that they touch and feel that they can use as a reference point to keep all of this very diverse work engaged in a coherent way. Now, in the same way, the challenge becomes a boundary object. It becomes something in which people, regardless of the discipline or background that they come from, something that they can touch and feel and that will serve as a reference point. Let me give you an example. Again, I'll drop from a green chemical problem. We posted a challenge which we titled Robust Electrical Contact to Glass Without Lead. Obviously, the environmentally attractive part of this is that we were doing it without lead. The manufacturers that use lead, and in this case, the lead was used in a molten form, so even more environmentally unfriendly than cool metallic lead. They were using this as a way of bonding, and I talked with the scientists that oversaw this project, and I think I'm at liberty to say that this was actually a way to manage the installation of the defrosting systems on the rear windows of automobiles. But they needed a way to bond this electrical device to the glass surface in a way that it wasn't going to peel off. Now, the challenge itself, and you can only see the overview of it, you can read here a high level of what was posted, but we present a challenge at 3 levels of detail. We present a title and an abstract, and that's the first filter by which solvers can decide whether they want to or are qualified to engage. We then go to an overview, which provides some additional detail. And at this point, they haven't had to pass through any of the intellectual property commitment filters or anything else. They're not under any type of specialized secrecy agreement. But to get to the most detailed level, they do have to pass through that gate within our environment. And when they do pass through that gate, they're under legal obligations to honor the confidentiality of the seeker, and the seeker is under obligations to honor the contract with the solver should they meet the criteria. And so prior to that, you see what is shown here, and I'm not at liberty to take all of you inside of a confidential room, but inside the confidential room, you'll see that the challenge is articulated in a way that talks about what things have been tried in the past. And why they don't work and why they're not acceptable. It talks about what the specialty requirements are. It really escalates this challenge to the point of becoming a boundary object. So in this case, it says there were 329 active solvers. Of those 329, probably less than 1% would have been familiar with the actual application in the automotive environment. And they wouldn't even know whether they had a contribution to make in advance. But once they see the details, and again, they've self-selected to be under that commitment, once they see the details of this, they realize that they did have a contribution to make. Now, in this particular instance, I believe it was something on the order of 39, I think 39 was the number, submissions that actually came in. Now, those did not come in, as I said, from the automotive industry. They came in very laterally, and it turns out that the solution, which I can't give in detail, but I can give in general terms, was a electrically conductive, non-metallic material which bound well to the glass, which the seeker was vaguely aware of but had discarded for fears that it would be too complex and too costly. The submission came in explaining how this could be accomplished in a reasonably straightforward manner, and altered the way that this work was done by our seeker client. Now, I've kind of talked about the boundary objects by taking you through that specific example, so I'm going to move on. I'm just going to wrap up with a couple slides here because I do want to get to questions, and I think we're counting down to the target time here. The alternative is often put forward to say, yeah, but maybe it's really a matter of diversity of thinking, and we need more creativity within our organizations, and we could solve these same problems in a closed environment. So, as a bunch of scientists, technologists, and engineers, you'd really like somebody to have done a study in which they compared crowdsourcing with internal closed innovation and everything else. And we weren't in a position to do that, and we didn't even know it was being done. But unbeknownst to us, Roche, the pharmaceutical manufacturer, was doing this. They ended up publishing in the London Business School journal MLab, in which they talked about a problem that they had been working on for 15 years. And in that 15-year period, they had used all of their internal access to resources, and they had tried to engineer as many possible solutions as they could to solve this problem. It had to do with inline quality control, something as it was being produced. And then they turned around and said, now we want to broadcast it using knowledge management tools to everybody inside of the Roche Corporation and see what kind of ideas we get from them. So they exercised that way of solving the problem. And it turns out they got quite a few good ideas. It was kind of chaotic, and things came in a haphazard way. And we could have explained to them a priori why that was likely to be the experience they were about to have. And then, again, without telling us that this data was in hand, because they were working with faculty at LBS, they posted it on InnoCentive. Now, I've just taken a couple paragraphs from, you can read those paragraphs maybe more at your leisure, but the result was 113 proposals from around the world. Quantity and quality took Pavilion, that was the overseeing scientist, and his team by surprise. This was accomplished in a 2-month period. In 60 days, they had replicated in this package of 113 submissions, they had replicated every idea that had been conceptualized and executed in the previous 15-year period. And as Todd says, he said, I couldn't have possibly put the people in the room nor conducted it for the cost effectiveness of what we got out of it, and I'd have ended up with a pile of sticky notes instead of separate detailed proposals. So it gives you an idea of, in general, why crowdsourcing brings solutions to problems that have been resistant even over decades of time, and I could cite other examples as well to internal work. As my final slide, I have looked at some of the, we don't label our problems green chemistry. We don't stamp them that way. So I just looked through a collection, a bucket of problems that we've worked on and solved. I picked only ones that we have solved to give you an idea. And the first one I talked about in some detail, where we frequently are looking for new, better chemical routes. And those better chemical routes can often be to obviate non-green parts of the process. We've removed contaminants from recycled products to make the recycled materials more pure and more competitive with non-recycled materials. We're frequently replacing solvents, not only in chemical processes as I described, but in specialty applications. We had one challenge that was noteworthy to us for a variety of reasons, in which they were looking to replace the hazardous materials used in art restoration, new reagents and solvents in a variety of commercial processes, removal of unwanted contaminants in everything from consumer products, natural gas. There's a lot of misspellings in this. I apologize for that. I'm going to fix those. From natural gas to food items, new polymers that have better, more environmentally sound, more sustainable properties for food, medicine, construction, et cetera. And I gave you a specific example of new commercial processes to obviate contaminants like lead. So with that, I will put it to this last slide, but open it up for questions and hand the floor back to Monica. Monica, thank you.
Thank you so much, Alph. Very interesting presentation. This is a new topic to our group, and we're very thankful that you've come to introduce us to this concept. Thanks so much. And I'd like to, yes, get the Q&A part of this webinar going. We do have a few questions in the queue, which is great. And for those of you that still have a question and haven't typed it in, don't forget it's the control panel on the top. Click the down arrow and type in your question. So let's see. Let's get going on this. So I think toward the end of the presentation you did kind of elaborate on this, but we have a question about the business model for InnoCentive. You had mentioned an example where 245 solvers responded, and this person, Tom Lent from the Healthy Building Network, he is wondering about whether what was offered was primarily solutions, sort of speculative solutions, where the solver was hoping to be awarded some funding to pursue the solution further, or that they actually had a solution in hand that they were able to provide to the seeker.
So to answer the question, these are almost always, that doesn't have to be 100.0% of the time, but almost always 99.9, a call for solutions, a call for things that solve the problem, not a call for grant submissions for funding to advance one. Now, we have different layers of criteria that have to be met. We have what we call the ideation challenge, in which we are looking for the top of the mind. We are trying to quickly survey what's in the minds of potential problem solvers out there. We have the theoretical challenge, in which we are basically asking you, write me a white paper, back it up with the literature, give me some references, and convince me that the idea you're submitting is going to work in my application. I'm going to tell you enough about my application to enable you to do it. We have the reduction to practice challenge, in which we say, solve the problem and tell me about it after it's solved. And you will be compensated or awarded based on a solution with the accompanying demonstration of its effectiveness. In some cases, if we're asking for, say, the synthesis of a compound not known in the literature, they're submitting to us white powders along with NMR spectra. So, you know, we can go right down to the level of detail that says, show us you've done it. So depending on the problem, depending on how much a seeker is willing to disclose, and a lot of other factors, you know, the more criteria you put in front of it, the more it's going to filter out the diversity of solutions. But on the other hand, it can basically hand you a ready-to-implement problem that is already solved. So we can do it to varying degrees, but they are very, very rarely a call for grants.
Okay, perfect. That's very helpful. And let me ask a follow-up question to that. To what degree does InnoCentive help your client, the seeker, to structure the problem, to either break it down from a big question into the mini projects as you described it, or to select more of an ideation type project or a theoretical type project? Do you help the seeker structure it to be most effective for them?
Yeah, the answer is absolutely. In fact, it's a part of the secret sauce. It's a part of the business model. Tom asked a little bit about the business model. The business model is you will pay us to post it. You won't necessarily pay the award unless it's solved, but you'll pay us to post it. And part of the services provided in that is not only the distribution services, but the articulation services. We have people who have been through this drill so many times that they know when you're probably even unaware that you're using limiting jargon in articulating the problem. So we undertake a process which we call flattening. We flatten the problem so that it is accessible by a variety of disciplines outside the discipline in which the problem exists. We would not have posted the bonding of glass to lead as an automotive problem. It would have automatically eliminated people from thinking they were even qualified to solve it. When we work with NASA, we don't post it as a problem in space medicine. We post it as generalizable, as flat of a problem as we can, and that's how we bring in a lot of lateral solutions. It's to be honest, it's part of the secret sauce. It's part of the services that you get by engaging in a third-party supplier of these tools, as opposed to saying, well, I've got a website, why don't I just do it myself?
Great, thank you, Alph. This is a question from Joel Tickner. Tell us about the solvers. Where are they coming from? Are they coming from other companies? Are they coming from academia? Are they private individuals, retirees? Describe that community for us, please.
So he just gave me 4 categories there, and I would say all of them strongly represented. In fact, we kind of imagined at some point, this might be hugely skewed towards, say, academic labs in economies without the same granting opportunities. Russian academic labs, Chinese academic labs, in which you would have the skill sets. But it turns out it was just much more diverse. It is retirees. It's the nerdy guy hiding in his basement in Nova Scotia. It's all kinds, but they do tend to have a few things in common. If you mapped advanced degrees around the world, you'd get a map that looked very much like our solver population, our registered solver population. They tend to come from those regions of the world and are concentrated there. Now, that's to say, there is not a country that is not represented somewhere in our pool, but in terms of density, it would look like a lot of what you would imagine for technological skill density. We have an abnormally number of advanced degrees. Something like 60% of our solver population have advanced degrees. It turns out they solve problems that originate in fields outside of the one they got their advanced degree in, but nevertheless, there's some critical thinking, there's some problem-solving filtration that goes on that helps define an effective solver population.
Great. Okay, and we have a question from Al Innes, who is posing a question that really is also a follow-on to this. He's wondering how you built this community of solvers. How did you find them? How did they connect with you? Do you reach out to them? Do you follow up with them? Well, what's your relationship with these folks?
So initially it was literally hand-to-hand combat. The marketing officer, myself, the CEO at the time, I mean, we were just on the road all the time, and we were in India and China and the Eastern Bloc and places where we knew there to be good minds, possibly underutilized. And we built the solver population to the point of 5,000 or 10,000, and we began to notice a different effect. We noticed that the rates at which problems got solved just shot through the roof. It seemed to reach some critical mass. Up there, we're at 300,000 now, so we continue to grow, but we also at the time we're only doing chemical problems. So 10,000 per subdiscipline might be a rough estimate of the critical mass needed in an effective solver population when you really want to get radically different ideas coming on board. So we built it initially that way, as I say, hand-to-hand combat, flying around the world. But once it reached a certain mass, we now have a lot of challenges where we post, and if we post a $25,000 bounty on it, we'll say $2,500 goes to whoever refers the solver to us. So people now look at it and then they say, hey, I think my colleague might know something about this. They pass it on to a colleague. They become a part of the network. So it's self-bootstrapping at this point. We don't have to do a lot other than, as the questioner said, do we communicate with them? We do on a regular basis. We notify them when new challenges go up. We have a series of community engagement activities. Hardly what you'd put in the Facebook category, hardly, because what they really want to see is the next interesting problem, and that's what we supply them. But it is a way to provide some stickiness to the population, and we're sure there's turnover within that population as well. The goal is to maintain sufficient critical mass that our seekers get served by the problems getting solved.
Great. Okay. Can you dig into the IP part of your business model a bit? How is it handled? Are there different strategies depending on what the seeker is looking for? What are the options for IP management?
Yeah, there are several options, and we've got some shorthand ways of doing this, so that when a solver logs in, sees a challenge, they very quickly know what the IP terms are. And so they kind of run the spectrum from you're obligated to transfer your IP exclusively to the use of the seeker client on this. Now that's something that I think you'll probably find in no competitive product out there. So we do have the ability to transfer exclusive intellectual property rights, and we've got the contracts that we've done this on, hundreds of cases that we've proven in the past. There's also the non-exclusive right to practice. This tends to be the one that almost all of the government agencies want. They want the right to use this, but they don't mind if you commercialize it. The solver commercializes it independently of their right to use. So right to use transfer is very common. Then the one that a lot of foundations use, we want this to enter the public domain. We want it to become available for everybody to use. And so we've got these different layers of intellectual property agreement. We've worked through all of them. We've simplified it down. In addition to, if you recognize that every open project requires a contractual agreement, InnoCentive has probably executed more intellectual property agreements than any Fortune 100 corporation. Because we do it, I showed you plenty of examples in which there were 2 and 3, and sometimes there are 500 and 600 individual solvers with a client on the other side of the paperwork, and we execute all of these agreements a priori going in, and then we execute them coming out. We get them all put on ink on paper before awards are issued.
Okay, very good. That's helpful. This, of course, this issue of intellectual property comes up time and time again in our Green Chemistry Innovation webinars.
Yeah, and I'll just say that it's another reason for using someone, an inexperienced intermediary in working with these, because let's face it, that can be a nightmare, and the asymmetry of having a DuPont on one side and, as I mentioned, a Nova Scotian basement inventor on the other side, it gets pretty, can get pretty complicated. It can, and you don't accomplish the goals of open innovation if you turn everything into a 90-day exercise between the lawyers on each side of the fence.
Right. Okay. Okay. Here's a question from Howie Zaretsky, and happen to know he's involved in IP issues, an attorney working in IP. Do solvers get compensated for submitting their solutions, or only the one chosen by the submitter of the challenge?
In general, it is the latter. It is only the one submitted, although we do have, and this is particularly frequent in ideation, in which we require the best submission win only for an ideation challenge. We require that the best of the submissions is the winner, and they sometimes like to award first, second, and third prizes. And so they're tended, and that's usually articulated, well, it's always articulated up front, so they can see, what those awards will be. And in cases, though, where there are criteria that have to be met in order for an award to be paid, those are usually paid to one, but sometimes they'll get multiple submissions, and they'll want to ring-fence some intellectual property area, and they'll pay 2, 3. We've had them pay up to 5 different submissions, in which each of the submissions could be a viable solution. They wanted to own the whole intellectual property estate around it, so they paid 5 different solvers.
Okay.
And a lot of seeker flexibility is the answer to that question.
Okay. Sort of back to the IP issue, do solvers worry, this is again from Tom Lind, do solvers worry about giving away their idea but not getting the award?
If it is a non-ideation challenge, a theoretical, a reduction to practice, or 5 or 6 others that we have, if it is a non-ideation challenge, the terms are that if they are not issued the award, all intellectual property rights revert to them. They are not under any obligation to the seeker. Now, they're under obligation if they learn confidential information inside of the detailed challenge room, but that's a confidentiality obligation. Their intellectual property rights revert back fully to them. Ideation grants the right to use upon submission. But it's only ideation challenges. And again, the solvers are knowledgeable about this. They choose whether they engage with any one challenge. In general, we imagine that at the beginning that a lot of solvers would say, well, I know the answer, but I'm not going to tell you until you write me a check for $1 million. And it just turns out that's not what happens. They don't. That is not their mode of engaging or behaving. Not to say it hasn't happened. I probably think of 1 or 2 emails like that, but in general, that's not what happens. But they are granted their intellectual property rights if they are not paid.
Got it. Okay. All right. Another question from Howie Zaretsky, and we're 1 minute over, so we're going to close with this. He's interested in whether folks are applying this concept using InnoCentive to solve mechanical or electrical-based technical problems. I know we've asked you to focus on the chemistry and green chemistry applications, but maybe you can throw out an example of
we have what we call a pavilion, which is a subset of the problems posted on our website that are topically organized or sometimes organized by a sponsor. There are a lot of mechanical problems. I would say fewer electrical. It's not zero, but fewer, but a lot of mechanical problems all the way from, manufacturing process design, mechanical engineering of processes to orchestrating some military applications. I mean, the mechanical applications are pretty broad.
Great, thank you. Good. Okay, well, thanks so much, everyone, for the great questions, and Alph for your phenomenal answers, very illustrative of the InnoCentive model. We're very excited to learn more about it. This is just a very quick question. I just have to know, do you do workshops for companies to introduce them to InnoCentive and sort of work through examples of how you get started to work with InnoCentive, in-person workshops as opposed to just webinars and conference presentations?
We do, of course. I mean, as part of our sales engagement, we have quite open dialogues with our potential customers. But then once they become a customer, we have what we call an on-ramp procedure, which is a series of structured processes that will go down as deep as actually extracting and conducting brainstorming sessions with subgroups within their organizations to get the appropriate challenges and actually build a portfolio, a pipeline of challenges to be constructed, worked on, and articulated and posted. So we have a whole process there that we refer to as on-ramp.
On-ramp, good. Okay, well, we might like to talk to you about that in the future, maybe as a forthcoming GC3 focused workshop with InnoCentive around that. So that's
could be
great.
fun.
Well, thank you. Yeah, that would be really fun. Thank you, Alph, so much. Thank you to everyone that has spent the last hour with us. And I just wanted to say, you see that slide up on your screen. We have 2 webinars coming up as part of this series. We haven't found dates for them yet, but we will be having a webinar about the Pharmaceutical Roundtable, which is part of the American Chemistry Society's Green Chemistry Institute program. We'll be talking about their research grants to academics to do green chemistry research that's relevant to the pharmaceutical industry. And then we will also have one coming up on the Launch Systems Challenge, also a challenge-driven innovation program to advance sustainable materials, specifically focused on textiles. So we'll let you know about that. So thank you, everyone. Thank you, Alph, so much for pulling all this together and for your time today. And thank you to all our participants, and we look forward to seeing everyone on future webinars. And by the way, this is being recorded, and we will be sending out information on where to find the link to the audio archive. So tell your friends, if they haven't had a chance to join us, they can still listen to the archive. Thank you, Alph. Thank you, everyone. Have a wonderful afternoon. Bye-bye.
Thank you, Monica, and all. Bye.